What's going on, guys? Welcome back. Hope everybody's having a good day. Part of the issues that we have seen over the past 3-4 years, especially in the last 2 to 3 years, is the issue with scaling with the more popular blockchains, specifically the proof of work blockchains. Bitcoin, for example, has always had issues with the fact that its throughput or transactions per second has always been slower than a lot of people would like. One of the solutions to that is the Lightning Network, which is a layer 2 sidechain, which actually will help scale Bitcoin by moving a lot of the operations to a more parallel state by pulling large amounts of Bitcoin into these state channels and then using a faster sidechain to speed up the transactions. Now, Ethereum is tackling the throughput problem by both side chains and by speeding up layer 1. And layer 1 can be sped up by implementing what is known as sharding. Sharding is something that has been talked about for a long time. It's been available in the centralized database technology area for quite some time. And this article here from inc.com actually goes into more of a high level about why sharding can really help a lot of blockchains that are currently being used. And then I wanted to jump into basically what exactly sharding is and side chains and kind of the difference between them. So this is kind of getting more the technical side of blockchains. So if you're interested, bear with me. Distributed ledger technologies are disrupting nearly every industry. A key question for blockchain startups is, should their network scale up or scale out? Scaling up means to boost the performance of nodes until they reach a 10x performance ceiling, since a network can only move as rapidly and as its fastest nodes. Scaling out can be much more efficient at 100x or more and requires what is known to as a sharding protocol. So what's being said here basically is that you can because these blockchains, especially the ones that are using proof of work, since anybody can join these nodes, they really are limited since every node processes every single piece of data. They're really as slow as the slowest link in the chain, so to speak. And what sharding actually provides is a way to kind of provide parallel processing at the layer 1 level. So not every node is actually going to be chewing on every bit of data that is being processed. Sharding and its various iterations can make DLT more secure, interoperable, and efficient, but more importantly, it makes blockchain scalable and sustainable by segmenting large amounts of data into digestible chunks, also known as shards. Public ledgers aren't actually as robust as advertised because of a crucial long-term problem, bloat. Bloat refers to the difficult technical challenge of permanently storing gazillions of blocks on chain, since a database immutability records are ecosystems info. The amount of data will eventually accumulate into gargantuan sizes over several years and decades. So every single node has to store every bit of data about every single block. And obviously that can grow into a ton of data, where it would be better to spread that data out, but still have a structure to it so that you can call on that data and also still have that data spread out over multiple nodes so that so it's decentralized. It's like having a big family who never cleans the garage until the junk can't fit. Many programmers suspect that information overload can wreak havoc if a system can adapt to increased use of higher traffic. Most DLTs work fine now, but they also haven't been around for too long. Data overload that will inevitably occur threatens future performance, reliability, and sustainability. Moreover, such a scenario could harm cryptocurrency valuations and destroy the network effects that a project's founders worked hard to achieve. For example, what happens if there are lengthy synchronization times between a wallet and network? With an overloaded network, downloading a wallet could take days, weeks, or more if its chain contains trillions or quadrillions of blocks, which can't be deleted. That is somewhat true. They have gotten around that with Merkle trees, which You don't really need to download all the data and all the blocks to have a wallet. But as these blockchains get bigger, I can see even just downloading the light, quote unquote, light versions of the wallets being a lot of data, which really isn't needed and would slow things down. So Sharding's approach to partitioning data. So enter sharding. In layman's terms, sharding splits a database into smaller chunks, which are then stored across several machines. Doing so balances a network's load across many nodes. There are various ways to implement the protocol, and scalability projects like Elrond are actively seeking optimal designs. Our sharding protocol spreads the load over multiple clients on different levels, says Benjamin Minchu, CEO and co-founder of Elrond. On the network communications level, it propagates messages into smaller networks, which decreases the communication overhead. Second is the transaction computation level, where sharding splits the network into smaller groups and process parallel transactions. This improves transactions per second performance. And I believe that this technology that's being talked about in this quote is specific to Elrond and might not be specific to the sharding that's going on with Ethereum and some of the other blockchains. The third level is state storage. Sharding partitions the blockchain and state's data so that only a fraction of the storage needs are necessary on that client. And this starts getting into the parallel processing point I was making before. Other crypto ventures are experimenting with sharding, such as Ethereum, Zilliqa, and Apollo. Elrond combines all three sharding types, as mentioned above, and call this protocol adaptive state sharding. Multiple shards are handled in parallel by different validators. The firm's founders believe that parallel processing is key to high performance and long-term scalability. The main advantage of sharding can only be attained if transactions are processed in parallel. That's the transaction computation sharding component. The CPU and storage hardware requirements of the clients do not need to be high, and this positively affects the state storage aspect. So again, not every single node needs to hold every bit of data about the blockchain. And beyond that, from the computing side, not every single node even needs to process every single computation on the blockchain. The more clients there are, the more shards a network can create. The network can also process more transactions while using less storage. Every client has to keep an up-to-date version only of the blockchain and state data that are specific for its shard. So if there are 10 shards, only 1/10 of the entire blockchain and state data has to be stored on each shard. What's the expected result? A 10x increase in network performance. So I could imagine too, there's a lot to think about when thinking about sharding. If a specific shard is being accessed quite a bit, or an application that is stored on a specific shard is very popular, obviously that shard would then grow because it needs more computational power. I could also imagine that you could even shift nodes over to a specific shard dynamically in order to boost performance on a shard that maybe needs more storage space or needs more computational power. And I believe that these are all the things that are being worked on. Specifically, I know Ethereum is working on this stuff, and it's been delayed multiple times because it's not easy to accomplish. As you can imagine, you're dealing with these giant distributed ledgers and then trying to shift computation power to specific parts of that blockchain that are split into these shards, not only for data storage, but for computing, for processing the data on those blockchains as well. So then it gets into benefits and speed. I think it covered kind of everything that, yeah. So this kind of goes into the low throughput of Ethereum and Bitcoin, which everybody probably knows about. It says that they both do 30 transactions per second. It's not true. Maybe that's the theoretical, but Bitcoin really does a maximum of about 6 transactions per second, and Ethereum does about 16. I think that's what they've been clocked at maximum speed-wise. So obviously, implementing sharding would be a huge help at layer 1. I don't think we'll see a change like this to Bitcoin ever, because they're working more towards things like the Lightning Network on layer 2 to speed things up. And as Bitcoin becomes more and more a store of value rather than a being used as a payment network, we might see these second layers like Lightning actually become more of a payment network. And then layer one will always be kind of the classic Bitcoin network that we know of today. And honestly, with SegWit and some of these other technologies that were implemented, Bitcoin's been okay, even with some of this higher traffic that we've seen. It's not perfect. It could be improved, and maybe it will. So quickly, I just wanted to go over the difference between, now that we've gone over sharding, but also sharding and sidechains, since they both increase performance, but they do it in different ways. Sharding is considered a layer one solution as it is implemented into the base level protocol of the blockchain. It basically divides the network into teams. After fractioning the network, each node is responsible to process its own transactions. Sharding has been around for centralized databases for a long time. For centralized databases, this sharding works very well as it has a centralized entity and is almost immune to malicious actors interfering with the database. Applying to shard to a decentralized database is a whole new ballgame, as there will be ill-intended nodes trying to corrupt the network. The safety mechanism that will be implemented in proof of stake blockchains that opt for the sharding solution is the fact that the malicious actor is unable to choose a specific shard to work on, and it does not know which shard he or she will be assigned to in advance. Projects that aim to implement sharding as a scalable solution are Ethereum, Zilliqa, and Cardano. We know Ethereum has been developing a sharding solution for a long time now, and Zilliqa recently postponed their mainnet launch until somewhere in 2019, which makes one wonder if we have the time to wait for sharding to be fully developed in order to solve the scalability issue. There are some rumors going around that sharding will be implemented in the Ethereum blockchain in 2020, which is still the goal, I believe. I know that they're laying the groundwork to implement. They're doing the hard fork, I believe, in January for Ethereum that will lay the groundwork for moving towards sharding and Plasma, the side chains that will help speed up. So layer one sharding is really about speeding up layer one of a blockchain by segmenting the blockchain to provide parallel processing at layer one, as I said like 4 times. Now, moving on to sidechains, which are a little bit different. You can see a little visualization here of sidechains. A sidechain is a separate blockchain that is attached to its main chain using a two-way peg. Sidechains are aligned in parallel with the main blockchain. The sidechain technology has been around for some time. It first appeared in 2014 when Dr. Adam Back published a research paper called Enabling Blockchain Innovations with Pegged Sidechains. Sidechains will allow for digital assets from one blockchain to be used in a separate blockchain, and if needed, they can be moved back to the original blockchain. The benefits of implementing sidechains in decentralized networks are huge. For instance, take the gaming industry. Let's say you are playing a popular decentralized role-playing game and your character has just found a unique in-game item that was hidden in a specific world. Your friend has just discovered a new decentralized RPG that he started playing. How cool would it be to be able to airdrop your character, including all of its achievements, into the new game that your friend is playing? You can show him your unique item in this new game. That's only one of the advantages of sidechains. Some blockchain projects might also refer to sidechains as child chains, which the main blockchain being the mother chain. I actually don't think that's a really good example. I think the Lightning Network is a perfect example of what a sidechain can do. So the Lightning Network is another example of a child chain and a mother chain, where the Bitcoin blockchain is the mother chain and the Lightning Network is the child chain. So you have the Lightning Network, which actually performs a transaction on the main chain, which is written, all the way down with a hash, so it cannot be messed with. And then all of the transactions that are done with that bulk of Bitcoin that is pulled into the Lightning Network doesn't have to be written to the Bitcoin blockchain until that state channel is closed. So that's one of the better examples. I do have a video on the Lightning Network, which is popping up now. It's one of my older videos, but I do go into some detail about how Lightning works on a higher level, so you can check it out if you're interested in that. But I just wanted to go over kind of sharding versus sidechains, how they are going to be really changing and speeding up blockchains in the future. If you liked the video, please give me a thumbs up. Please share the video if you liked it. And I'd love to have you as a subscriber if you are new here and are not subscribed. That's all I got for today. Thanks. Have a good one.